Hey everyone, welcome to another session of Ceerazzledazzle Physics. In today's session, guys, we're going to be looking at AQA GCSE Physics Higher Tier Paper 2, June 2020, everyone. And this will be a full exam paper run through. So I'll do the entire paper. And obviously the main thing is that you've got to do the paper yourself before actually watching this video. Otherwise you've just wasted the paper. So do the paper yourself and then use this video to check my working and see what my thinking was. 1. A student investigated the acceleration of a trolley. Figure 1 shows how the student set up the apparatus. So here we are, we have the trolley on over here, we have a ramp, and over here we've got a data log and the light gate here. Wooden block bench, sloping runway, a mass holder here. So you're going to add masses over here, and I'm sure it's going to pull the trolley down here. Before attaching the mass holder, the student placed the trolley at the top of the runway. The trolley rolled down the runway without being pushed. What change the apparatus could figure 1 be made to prevent the trolley from starting to roll down the track? What could you actually do? How could you make it not roll down the track? It's simply going to be this, guys. You can actually move the wooden block to the left over here. If you move it over here, it's less likely to be pulled this way over here. So the answer to the first one is going to be here. Move the wooden block to the left. Okay, next one, 1.2. The student attached the mass holder to the string. The string rubbed against the edge of the bench as the mass holder fell to the floor. So just what the student could do to prevent the string from rubbing. Right, so what they could do is actually add a little pulley. So a pulley, hopefully you've seen it, like a little wheel, and obviously the string can now rest on top of the pulley and then fall down over here. So that's what you can add here. So this pulley here, which will enable it to spin, and therefore there's less friction, less contact over here. So the answer is going to be, we can use a pulley. So use a pulley. Okay, use a pulley. Next one, it's going to be the light gate and data logger we used to determine the acceleration of the trolley. The student increased the resultant force on the trolley and record the acceleration of the trolley. Table 1 shows the results, and as you can see, you've got resultant force in newtons, acceleration in meters per second squared. Figure 2 is incomplete graph of the results. Incomplete. So you've got to be able to plot them, everyone, over here. So first of all, you've got to choose the correct scale. So resultant force, you know it's going to go up from 0.05 to 0.025, so I'd go from over here. Let's go for, so I'm choosing a scale of over here. We can go, this is 0.05, 0.1, this is 0.15, and then the next one 0.2, and then the next one over here, this will be 0.25, so 0.25. Obviously I've looked at the scale. I've needed to make sure that I've incorporated that into my axis over here, and the values over here is going to be 0.08, so it's there. As you can see, guys, I've plotted the points correctly, so you get 1 mark for choosing a suitable scale. You get another mark for saying that you've actually plotted the plots correctly, and then don't forget we need to have a line of best fit here. So you're meant to have a line of best fit over here. So, you know, drawing 1, obviously, over here. Take a ruler if you can able to draw it. We're drawing a line of best fit on our results here. 1.4. Describe the relationship between the resultant force on the trolley and acceleration of the trolley. Well, you know that as one goes up, the other one goes up at a linear rate. So it's proportional, guys. This one's going to be proportional. Don't forget direct proportional if it's going through 0, 0. And 1.5, describe how the investigation could be improved to reduce the effect of random errors. What could you do to reduce the effect of random errors? Number 1, you could repeat the experiment. So repeat the experiment, because when you repeat the experiment, you can spot the anomalies, and then you can throw them away. And therefore, repeating the experiment, then therefore you can ignore or you can discard anomalies. And from discarding anomalies, you can then calculate an average. And calculate an average. So don't forget, you need to discard the anomalies and then calculate an average here. 1.6, write down the equation that links acceleration, mass, and force. F is equal to ma. Work out this value over here. The resultant force is 0.375 newtons. The mass of the trolley is 0.6. Calculate the acceleration to 2 significant figures. F is equal to ma. Therefore, A is equal to F divided by m. So it's 0.375 newtons divided by 0.6. I'm going to put them into my calculator, and what we're going to get 0.375 divided by 0.6. I'm going to get the answer of 0.625 meters per second squared. That's going to be our answer. Oh, and don't forget we have to put this to 2SF, everyone. I would have lost a mark there, so it's 0.63 is my answer because it's to 2SF. 2.1, complete the sentences. The sun is a stable star. This is because the forces pulling inwards caused by gravity, don't forget, it tries to drag all the matter inwards, everyone, are in equilibrium with the energy being produced from nuclear fusion. Don't forget, in the stars, everyone, fusion takes place. Don't forget you have the hydrogen being fused into helium and the energy is released in that process. Write down the equation that links distance travelled, speed, distance and time. So first of all, we know that speed, the velocity, is equal to distance over time over here. Don't forget, although they've used the symbol s over here, so velocity is equal to displacement over time over here. There we go, so that's v is equal to s divided by t. Next one, 3.2. The mean distance between the sun and the earth is 1.5 times by 10 to the power 11 meters. Calculate the time taken. So we know that v is equal to s divided by t. Therefore, rearranging it, t is equal to s divided by v. The distance 1.5 times by 10 to the power of 11 divided by the velocity 3 times by 10 to the 8 over here. I'm getting the time equal to 500 seconds. So the answer is 500 here. 2.4. Some stars are much more massive than the sun. Describe the life cycle of stars much more massive than the sun, including the formation of new elements. Right, so it's a 6 marker over here. First of all, you've got to talk about the following. Number one, we know that you have a cloud of dust and gas. So we have cloud of dust plus gas. And what happens is gravity brings them together. So gravity brings dust and gas together. And then obviously as that happens, what happens is that this causes the temperature to heat up. So therefore the temperature heats up, and then finally the star becomes hot enough for fusion to occur. So finally the temperature is hot enough for fusion to occur. Yes. So for fusion to occur, guys, now we have hydrogen being fused into helium. So hydrogen fuses into helium, and then the fusion occurs up to iron. Yeah, so this keeps fusing from hydrogen to helium all the way up to iron. So this goes up to the element iron, and then obviously when you run out of fuel, so when hydrogen runs out, hydrogen will then run out. And as the hydrogen runs out, the star will expand. The star will expand to become a red supergiant. And then the star will explode and becoming a supernova. The star explodes, becoming a supernova. And this is where the heavier elements greater than iron are created. And elements greater than iron are created over here. And then finally it can become a neutron star or a black hole, and then finally becoming a neutron star or black hole. Okay, right, so there's quite a lot in here. You're thinking, oh my god, there's more than 6 points in here, but for a level 3 answer they are looking for scientifically relevant facts, events or processes are identified and are given in detail to an accurate account over here. So this is, you don't have to get this down word for word, but a majority of this should be there in your answer. It must be clear that you've talked about, number 1, the life cycle of the star from start to the end, and you've talked about the elements here. And look, I've talked about the elements. I've talked about hydrogen start, hydrogen fusing to helium, up to iron, and then when a supernova occurs, that's when you get the elements greater than iron being formed there. 2.5. Stars emit radiation with a range of wavelengths. Which property of a star does the range of wavelengths depend upon? Well, it's going to be the temperature here. 3. A student investigated the refraction of light at the boundary between air and glass over here. The ray of light from the ray box should be as narrow as possible. Explain why using a wider ray would give less accurate results than using a narrower ray. Well, the reason why is because it's hard to judge where the center of the ray is, so it's harder to judge center point of ray. And the next one's going to be therefore there's greater uncertainty. So therefore greater uncertainty. Excellent stuff. Figure 4 shows the results, and over here we've got a graph of angle of refraction in degrees and angle of incidence in degrees. Estimate the angle of refraction when the angle of incidence is 80. Okay, so you've got to draw a line of best fit. So look, it goes up over here, and yeah, it maybe go like that. That's what I'm probably drawing over here. And the answer, you're looking for any value between they accept between 40 to 43. Yes, and that should be roughly right. So 40 to 43, that's what you're looking for in terms of your results here. So obviously 40 to 43, that's roughly where you should find your mark over here when you've extrapolated your line. And the mark scheme, they've said 41 degrees, but look, any value between 40 to 43 is fine. 3.3, describe a method the student could have used to obtain the results shown in figure 4. So how would you actually obtain that? Yes, angle of incidence over here, and look, the angle of refraction over here. How could they do this? Well, let's have a quick read of the question once again. So it's going to be the boundary between air and glass. Okay, so the first thing you're going to have to do is you're going to have to place glass block on piece of paper. So place glass block on plain paper. And then afterwards, everyone, don't forget you're going to have to draw around the glass block. So then we're going to draw around glass block. After you've drawn around the glass block, then you're going to, using the ray box, so using ray box, you're going to shine the ray of light, shine a ray of light into the block. And then don't forget, you're looking at the amount of refraction. So the ray of light enters the glass block, refraction takes place, then it comes out. So therefore, you're going to mark where the ray goes in and mark where it exits the block here. Mark where ray enters the block and exits. And then after you've done that, guys, so then you remove the glass block and then you connect the line. So then afterwards, it's going to be remove glass block and connect the points. After you've done that, everyone, then you can measure the angle of incidence and angle of refraction. So measure angle of incidence, measure angle of incidence and angle of refraction using a protractor. And after you've done that, everyone, then you're just going to repeat for different angles of incidence. There we go, repeat for different angles of incidence. And obviously look at the graph that they've got over here. They've got the angle of incidence every 10 degrees. So every 10 degree interval, at 10 degrees interval. The last point at 10 degrees interval. At 10 degrees interval. 3.4, the student repeated each measurement 3 times. When the angle of incidence is 40 degrees, the 3 measured values of the angle of refraction are 28, 25 and 22. Estimate an uncertainty. To work out the uncertainty, all you simply do is going to be equal to the maximum value minus the minimum value divided by 2. So the maximum value you've got here is 28 minus 22 divided by 2. The answer is going to be 3, everyone, here. The answer is going to be 3. 3.5. What property of the light wave changes once it's refracted? Well, don't forget the colour remains the same. The frequency remains the same. It's the velocity. So the velocity will change as it enters a new medium. 4. A door is fitted with a security lens and a lock. The security lens allows a person to see a visitor before opening the door. The security lens is concave. Figure 5 is an incomplete ray diagram over here. Complete figure 5 to show how image of the visitor is formed by concave lens. So it's a diverging lens. So the first ray of light I'm going to draw is, I'm going to go for, I'm going to use a shape for this. Let's go for, we're going to go for a shape. Let's go for just draw a line. So the ray of light, there we go. So you draw it from the top of the object, guys, go through the center of the lens. That's your first ray of light over here. Then you draw another ray of light, this one going horizontally across over here. I'm going to be able to see that. And then I'll just make that red. There we go. And then don't forget, because it's a diverging lens, it's going to go away. Hit the lens and it will be moved off at an angle. So look, it moves off at an angle, and look, it matches up with the focal point over here. And don't forget, we're going to extrapolate this line backwards now to see where it meets the other ray. So we're going to copy this, just going to paste it over here. And as you can see, guys, I've extrapolated that line backwards now over here. And don't forget the arrows. So obviously the ray of light goes straight down for this one goes straight off at an angle. And then extrapolating this line backwards over here, this is where the image is formed. This is where the image is formed over here. That's where the image is formed, and that's 3 marks over here. 4.2, the visitor moves further away from the security lens in the door. How does it change the actual image? How does it change the actual image? Well, hopefully you can recognize that as the visitor moves further and further away, this image will get smaller. Yes, imagine if I drew it over here, the angle gets a bit smaller each time over here, so it will decrease. Figure 6 shows the diagram of a lock. The door unlocks when the switch is closed. Which material should the bolt be made from? Well, obviously it's about magnetism here, so I'm looking for magnetic material. It's going to be iron. 4.4, explain when the door unlocks when the switch is closed. Right, so when you connect the switch, what happens is current flows through the coil, yes? And therefore a magnetic field is induced in the solenoid. So number 1, current flows through solenoid. And as the current flows through the solenoid, number 2, a magnetic field is induced. And as the magnetic field is induced, look, it's in yellow. What will happen is it will attract this bolt because the bolt's made out of iron. And therefore, number 3, bolt is attracted as made out of iron. And there we go. Obviously that answer should be at the bottom here, but I'm just putting it over here just to save some space. When the door unlocks, a force of 2.88 newtons is applied to the spring. The spring extends by 1.5 centimeters. Calculate the spring constant. So F is equal to K times by E. K is equal to F divided by E. The value of the force, 2.88. The value of the extension is going to be watts. We have to convert that into meters. It's 0.015. So it's 0.015 over here. So therefore the value of K is going to be 192 newtons per meter. Give two ways the resultant force on the bolt could have increased. So how could you make the force experienced by the bolt increase? Well, it's about the magnetism. If you look back at this diagram over here, obviously you put a stronger current in, you get a stronger force over here. Also, you can actually increase the strength of this magnetic field by winding the turns closer and closer, so increasing the number of turns on the solenoid. So number one, by increasing the current, so increasing the current in the solenoid, and also increasing the number of turns on the solenoid. 5. Figure 7 shows two ice hockey players moving towards each other. They collide and then move off together. So there you go, these are going to collide. During the collision, the total momentum of the players is conserved. What is meant by momentum is conserved? What exactly does that phrase mean? It simply means that the total momentum before the collision is equal to the total momentum after the collision. There we go, the total momentum before the collision is equal to the total momentum after. Right, next question. Immediately after the collision, the two players move off to the right. Calculate the velocity of the two players immediately after the collision. Okay, so for this, I'd actually draw it out over here. I'll have one diagram and another one over here. So both of them, first of all, they're moving towards each other. Afterwards, they collide and they stick and they both move off to the right over here. So initially, let's just write down the values. We've got the values of 78 and 7.5. So the mass of this one is 78. So the mass of this one is going to be, this is 78 kg. And it's moving at 7.5 meters per second. So meters per second to the right. The other one's going to be, the other one is 91 kg over here. And it's moving at minus 5.5 meters per second. Yes? Don't forget, this is the same diagram as before. I'm just doing it before and afterwards. So this is my before picture, and obviously this is my afterwards. Yes, what's going on here? Then I can simply write down the sum of the momentum before is equal to the sum of the momentum afterwards. Right, so therefore the sum of this momentum, so this one, so it's momentum of the first one, let's call this one A, let's call this one B. So momentum of A plus momentum of B will be equal to the combined momentum of A plus B, because they're both moving off together. I only have one momentum here. Momentum of A, it's going to be 7.5. Don't forget, it's the mass times by the velocity. So 7.5 times by 78. Then I'm going to add the other one, 91 times by minus 5.5. That will be equal to this one. So don't forget, they combine mass together. So the 91 plus 78. So 91 plus 78, it's going to be 169. So 169 kilograms. So the total mass of this one is 169 over here. And the velocity, that's what you're trying to find out, times by v. Right, and then you're just going to solve it over here. So 7.5 times by 78, this one is going to be equal to 585 plus 91 times by minus 5.5 is equal to minus 500.5. That will be equal to 169v. So therefore, on the left-hand side, it becomes 585 minus 500.5. So therefore, this one becomes 84.5, yes, and then that will be divided by 84.5 divided by 169, yes. That will be your final velocity of what it all becomes. So divided by 169, I'm getting the answer of 0.5. So this answer, all of it, is equal to 0.5. Let's just change the colour of pen for that. It's equal to 0.5 meters per second. Tricky question, guys. So obviously make sure you fully understand how conservation of momentum works. I've got a whole video walking you through examples of this. Check it out. It's in the description. 5.3. The ice hockey player wears protective pads filled with foam. Explain how the protective pads help to reduce injury when the players collide. Well, what is the whole purpose of the pad? Number one, it's going to increase the impact time. So it increases the impact time. And therefore the force experienced decreases. So the force experienced decreases. And the reason why is because the rate of change of momentum has decreased, because the rate of change of momentum has decreased. Yeah, so this question's all about, don't forget there's a whole bit, F is equal to m delta v over t. Yes, the rate of change of momentum and how it affects the force and the time here. 6.1. The remote control transmits radio waves to the car aerial. The transmitted radio waves have a frequency of 320 megahertz. The speed is this much over here. Give the wavelength. Give the wavelength over here. Right, hopefully you can recognize that. Wave speed is equal to frequency times by the wavelength. You want to work out the wavelength is equal to the speed divided by the frequency. So 3 times by 10 to the 8 divided by the frequency, 320, careful, mega is going to be a million, so 1, 2, 3, 4, 5, 6, yes, hertz over here. What's going to be my answer? So it's going to be 3 times 10 to the 8 divided by 320, 1, 2, 3, 1, 2, 3. I'm getting the answer of lambda going to be equal to 0.9375, and that's going to be our answer here, 0.9375, and the unit, don't forget, it's a wavelength, it's going to be meters, it's the length of the wave. 6.2. The car aerial is connected to an electrical circuit in the car. Describe what happens in the electrical circuit when the car aerial absorbs radio waves. So if you've forgotten, what happens is that when the car aerial absorbs the radio waves, the electrons oscillate. So there we go, guys, the electrons oscillate in the aerial and they have the same frequency as the radio wave. At the same frequency as radio wave. Next one, the car produces sound waves. Give two waves in which the radio waves are different to a sound waves. Explain the reason why. So radio waves, first of all, so radio are transverse, sound is longitudinal. And don't forget the radio waves travel much faster than sound. Yes, so the radio waves travel faster than sound. Excellent stuff. Figure 9 shows a distance time graph for the first 30 seconds of the car's motion. Okay, describe the motion of the car during the first 30 seconds. Right, it's distance time. First of all, it's not moving at a constant speed because we can see the gradient is changing here. So it will be accelerating. Yes, accelerating. Because look, don't forget, a straight line means constant speed. It's not a constant speed right now. You can see that the gradient's getting higher and higher, so therefore the speed is increasing more and more. Therefore, if you have a change in speed, it's going to be accelerating. 6.5. Determine the speed of the car at 20 seconds after it started to move. Okay, so for non-uniform motion, everyone, you've got to be able to draw a tangent. So whenever you see a curved graph and you're trying to work out the velocity, you've got to use the tangent rule here. So from here, 20 is over there, we can do this. So 20, let's draw a tangent to the line. There we go, I've drawn a tangent to the line over here, and as it goes down over here and it goes across, that's going to be the tangent to the line here. And then you work out the gradient of this tangent. Once you've done it, guys, you should actually work out the gradient of the tangent. So the change in y of the change in x for this one over here. So it's going to be 5.6. They can do that a bit over there. Let's say it's 5.6. This one at the bottom over here, do it yourself. It's going to be 20. So they're 5.6 divided by 20. I'm going to get the answer of 0.28 meters per second. Don't forget where the marks come from. 1 mark for doing the tangent, 1 mark for taking the correct readings, 1 mark for the calculation, and 1 mark for your answer. A different car accelerated from 0.125 meters per second to 0.52 meters per second. The acceleration of the car is 0.04 meters per second squared. The work done is 0.48 joules. Calculate the resultant force needed to accelerate the car. So if you want the resultant force, you know it's going to be what we're going to be looking at here. Well, for me, I know that I've got the energy, so I know it's something about the work done. So the work done is equal to the force times by the distance here. So the work done is equal to force times by the distance over here. But we're not given the distance, we can work that out using another formula. So we can use the formula v squared minus u squared is equal to 2as. So from here, I'm going to rearrange it to find the distance, which is s. So s is equal to v squared minus u squared divided by 2a. So s is equal to the final velocity 0.52 squared minus initial velocity 0.12 squared divided by 2 times by the acceleration of 0.04 over here. You get the displacement going to be equal to 3.2. So 3.2 meters is going to be our answer for the displacement. And then look, now I can work out the force because I've got the energy from before. So the force is equal to the energy or the work done divided by the distance. So the force is equal to the energy 0.48 divided by 3.2. Bang. its force is going to be equal to 0.15. Yes, so that's going to be my answer over here, 0.15. 6.7, explain why the car has a maximum speed. Well, don't forget, the car obviously is moving in this direction at the start, but as it keeps moving, what happens is the air resistance starts to build up. Yes, so don't forget there's a driving force at the start, then as time goes on, the air resistance starts to build up. Eventually the air resistance will be equal to the force, so the force and the air resistance are going to be the same over here, so both of them are going to be the same. So we can put down the following. There is a maximum driving force, so number one, there's a maximum driving force, but as the velocity increases, air resistance increases, and as the air resistance increases, what happens is eventually they balance out. Eventually air resistance balances out the driving force, then car moves at constant speed and no more acceleration, Easy stuff. 7.1. The portable power supply has an alternator connected to a transformer. The transformer can be adjusted to have different numbers on the secondary coil. Explain the reason why. Right, the reason why you want to be able to change the number of turns on the secondary coil is because it will change the output voltage. So it will be able to change the output voltage. Yes, and therefore you don't require a different generator each time, and therefore you do not require a different generator each time. 7.2. The lamp is connected in a power supply. The lamp requires an input potential difference of 5 volts. An alternator generates a potential difference of 1.5 volts. The primary coil has transformed 150 turns. Calculate the number of turns on the secondary coil over here. Right, so this question looks easy at the start because you think it's going to be simply NP over NS is equal to VP over VS, yes? But the trick with this question is recognizing that which one is the output voltage and which one is the input one. Right, the lamp requires an input voltage of this. So this is going to be what we need to connect it to. So this is VS. And then the generator is obviously going to be VP over here. And then the rest of it is pretty easy. So if you want to work out the number of turns on the secondary coil, that's NS. NS is equal to NP times by VS divided by VP. The number of turns on the primary is 150. The voltage in the secondary, which you need, is going to be 5, which is at the top. The voltage in the primary is 1.5. My answer is going to be 500 over here. Yes, the answer is going to be 500. Really tricky question because, they try and confuse it because they have an input voltage, so you think that's the primary, but it's not. Don't forget the lamp is connected to it. That's why that's the voltage in the secondary. You need it to produce that voltage. Figure 11 shows the inside parts of the alternator. The handle of the alternator is turned, causing the coil to rotate. Explain why an alternating current is induced in the coil. Right, so don't forget what's actually happening here. You've got a north pole here and a south pole here, and you've got the coil over here. You are going to rotate the coil within the magnetic field. So first of all, we've got to talk about why we get an alternating current. So number one, coil is moved through magnetic field. Don't forget, you are turning it now, so you turn it. So as you do it, you're making it move through the magnetic field. Don't forget the magnetic field's going from north to south over here. You're now moving it through there. Number two, a potential difference, and this is the key word in all these questions, everyone, is induced. A potential is induced, everyone. A potential difference is induced, that means created in the coil. Okay, the next point is quite difficult because you can't see it in here, but why would you get a current and not just a potential difference? Is because it must be a complete circuit. So what happens is you have to say that there is a complete circuit, hence a current can flow. Excellent stuff. And then 4, don't forget, is that every half turn it will reverse direction. So the next one's going to be every half turn the current will reverse direction. So don't forget, every half turn it reverses direction here. So don't forget, right now it's going one way, then as it goes the opposite way it will swap direction here as the potential difference has been reversed. There we go. So look, every half turn the current will reverse direction as the potential difference has reversed. That's the 5th point, yeah, the potential difference has been reversed as well. 7.4, suggest the purpose of slip rings. It's going to be the reason why you need the slip rings is that to ensure there's continuous contact with the coil. So it ensures continuous contact with the coil and brushes. That's the reason why, yeah? So you want it to, don't forget, if you were to solder them together, it would spin and get tangled up. 7.5. An alternator from the portable power supply disconnected from the transformer and the lamp. Explain why the handle of the alternator becomes much easier to turn. Okay, so the reason why it becomes difficult is because now there is no current flowing through the coil. So there's going to be no current through the coil. No current through the coil. And if there is no current through the coil, there's therefore not going to be a magnetic field. So therefore there's magnetic field is not produced. Magnetic field is not created. And if there's no magnetic field, don't forget, if there's no magnetic field, there won't be any opposition to the motion. So therefore, there is no opposition. Therefore, no opposition to the motion. Yeah, this is really tricky. Yeah, this last point is really tricky over here because there's a magnetic field generated in the coil which opposes the motion, but now because you turn off the current, there is none of that force trying to oppose it. And that's it for another session of Ceerazzledazzle Physics. Make sure you hit the like and subscribe button to keep my channel going. And obviously make sure you go through the paper yourself, yes? Make sure you comment below if you have any queries and I'll do my best to solve them. Ciao, ciao and goodbye.